This is a presentation directed to a younger audience explaining our solar system, various star systems, exoplanets, comparisons, characteristics, and the science behind it. Sometimes you may have asked yourself the question, what is up in the skies, beyond the moon and sun and our solar system? The short answer would be, well, there's plenty of stars and planets gathered up in many different galaxies, but what exactly makes our solar system so different from all these other planets, stars, and their systems and those many galaxies? Our solar system is our home. We live on Earth, we have our sun and our 7 planet neighbors. And I'm sorry, Pluto, you're not a planet any longer. And we each rotate around the sun, which for us takes about a year. And the reason we rotate is gravity, which is the reason you always fall back down to the floor when you jump, but on a much larger scale. The sun wants Earth to move closer, but Earth is passing by so fast that it still manages to keep its distance to the sun, but is now forced to rotate around it. Imagine being a cowboy and throwing a lasso around a horse's neck while it's running by. You now have a grip on the horse, but you're not strong enough to pull the rope and the horse to yourself. So now you have a horse running around you until you let go, which you normally as a star cannot do. This is somewhat how planets and the so-called gravitational pull work, though our planets move in an elliptical orbit, meaning they're not quite circular, which is also the reason why we have summer and winter here on Earth. A smart German scientist by the name of Johannes Kepler many hundreds of years ago once described these orbits and made 3 important laws that every scientist nowadays knows. And here's an example of Kepler's third law explaining the correlation between the orbit sizes and the planet's mass, which explains why Neptune and Earth aren't close to each other but in their own respective orbits, for example. This also means that while Earth's complete rotation around the Sun takes a year, Neptune's orbit would take nearly a whole 165 Earth years to complete, and that is a lot of days. Okay, so this is how our home works. But before we leave, it is important to note that our Earth has an atmosphere. And the air you breathe, that's part of the atmosphere. It allows us and many other animals and plants to live here. But what happens if we step outside our home system, the solar system? First of all, we would move about in our home galaxy, which is obviously the Milky Way. And it's not the chocolate one, but it is this barred spiral galaxy right here, as it's called. At some point, we would meet other planets and stars in so-called star systems inside the galaxy arm we live in. The closest to our home system would be the Alpha Centauri. The Alpha Centauri star system consists of 2 stars, which can be called a binary system. The word binary comes from the Latin word bina, which means double or pair, which is a very interesting concept. There's another star close by which is called the Proxima Centauri, and this is where things start to get really interesting for us. Proxima Centauri is a red dwarf, not the kind of dwarfs you might think about, which means it's a relatively small and cold star, smaller and colder than our Sun even. But most importantly, there is a planet orbiting around the red dwarf. These planets are called exoplanets. Exo is Greek and means out or outside, so these planets are planets outside our solar system. With smart words, they can be defined as planets outside the gravitational influence of the Sun. A special trait of these exoplanets is that they orbit stars or red dwarfs, just like our Earth orbits around the Sun, which is also a star. Exoplanets can come in different sizes, some bigger than Jupiter and some even smaller than our Earth. Just like in our solar system, these exoplanets can orbit at many distances. They can orbit so close to the star that they are very hot and they could easily melt iron, or very cold, just like Neptune for example. This also means that, given the right distance to the star, these planets could possibly be as warm as Earth, meaning that water and life could exist on these planets if an atmosphere there is somewhat similar to ours. So that means we can send many people and astronauts to these exoplanets to build their homes there. When there's no more space on Earth, people can make the new exoplanets their home, and you could have extraterrestrial friends and family in the soon future. Of course, we still need very big and fast enough spaceships and very many astronauts to reach these planets, but the possibility of leaving Earth and calling another planet your home is very exciting. This raises another question too. Is there alien life in the universe? If there are planets like Earth out there, will we be the only ones, or are there other people or aliens? These exoplanets raise a lot of questions for scientists and are a very interesting challenge. How do these star systems in our solar system get created though? Let us take a look at how, for example, our solar system was created many years ago. It all started with the gravitational collapse of a part of a huge molecular cloud, which is a cloud of elements from the periodic table, mostly dominated by molecular hydrogen, which is H2, which is one of the most basic elements. This cloud collapsed, most likely because of a big supernova explosion which disturbed the cloud and pushed it together, resulting in the gravitational collapse, which sucked all the matter that was being blown away back together. The cloud of dust and gases was now spinning at a very high speed, and this is called the solar nebula, from which the sun and the planets will form. Also, other solar system bodies such as asteroids, moons, and meteors will be formed here. This cloud began spinning slower over time, which resulted in the center getting hotter and denser, while being surrounded by a disk of the gases and dust, which was still cool at the outer edge. And this disk is called the protoplanetary disk and surrounds a young, newly formed star. The center is now hot hydrogen gas, whose temperature and pressure were rising steadily until particles, that means very small bits of matter, fused together to become the sun. Particles of the protoplanetary disk started to fuse together as well, which eventually led to planets and other solar system bodies, depending on how many particles they could gather. And this also means that because the edges were cooler than the center, that the cold planets such as Neptune and Uranus are on the outermost orbits. A fun fact to consider is that the Sun is 99% of the mass of our solar system, while the rest makes up the last 1%. And this is the general way star systems are created, so we could assume it has played out similarly in other star systems, such as, for example, our Proxima Centauri. There is a remaining question. How do we find these exoplanets out there? It is quite difficult to find these exoplanets, and scientist teams all over the world are looking for them. One method is called the transit method, which measures the brightness of stars, so for example the red dwarfs. Once the brightness decreases, it must mean something is in front of the star, and once it returns to normal brightness, it must have passed. Since these exoplanets are so difficult to spot, scientists are forced to use these indirect methods to find them. There's a way we can learn more about these exoplanets and their atmospheres. One is called the transmission spectroscopy. When an exoplanet passes in front of a star, a little of the star's light passes through the exoplanet's atmosphere before it reaches us. And out from the color of the light, we can learn what molecules make up the exoplanet's atmosphere. Imagine you are holding a glass of apple juice up towards the sun. The light that passes through your juice will have a similar color to your juice. And this is somewhat the same method that scientists use to figure out what the atmospheres are made of. So now you know how our solar system and star systems are made, what exoplanets are, and how we can compare those to us in our system. The whole idea of exoplanets and star systems is not only to make us smarter, but also a mission to discover and explore the universe and find a new home once Earth may not be sufficient to us any longer. It may still take many years before we can fully take advantage of this potential, and for now it may still seem like a dream, but in the future it will definitely become a possibility and necessity. I hope I satisfied some of your hunger for knowledge with this little introduction to exoplanets and star systems. What I hope even more is that you're even hungrier for knowledge on this topic now. Science is fascinating, and I hope to inspire you with my little presentation to learn about science and all the fascinating possibilities. I hope you learned something and enjoyed it. Thank you for your time.